Good evening. My name is Amanda Anderson, and I am doing a slideshow on the effects of increasing space allowance by removing a pig or gait adjustment on finishing pig growth performance. And this is out of the Journal of Animal Science with Corey Carpenter and a plethora of other authors. So for my introduction, in this study, we're going to look at the effects of the amount of space swine were given, and how taking the largest pig out of the pen increases the weight collectively of the whole unit, the correlation of the space to the development and the well-being of the pig. We will determine if the space is the reason for increased overall volume of growth, or the social construct change of taking the largest pig out is the reason for the growth. So as far as the amount of space that was given as an industry and is currently accepted for swines is a critical K value of 0.0336, and that's meters squared. So the A is the area here, the K is the coefficient, and the BW is considered the body weight. As far as removing the heaviest pig, typically they do this, they remove the heaviest pig from the pen roughly around the 2-week period. And this is a common practice that has been implemented by the commercial swine industry. Studies have shown that the removal of the heaviest pig has marketed results as an increased growth rate for the remaining pigs in the pen. Now, it was not known whether or not the growth improvement from removing the heaviest pig was due to actually taking the pig out of the pen and removing it from a social dynamic matter, or if it's actually from the extra space provided that increased the weight. So the objection of the study is to validate the space allowance determined by using critical K value and comparing it to the effects of increasing the space allowance by pig removal or gait adjustment. So our methods. So this study was done in an environmentally controlled research barn. It is a solid-sided building. The pens were 2.43 by 3.05 meters, and they were equipped with adjustable gates to allow different space allowances for the pigs. There was a total of 256 pigs in this study. It was for a 71-day growth period. They were initially placed in the pens approximately 30 days prior to the start of the experiment. They started off with 7 to 8 pigs per pen. And here is a table of basically the study, and it's split up in between day rates, and it's basically measuring the values of the pigs and how much food they're eating and comparing it to the amount of space that the pigs are provided. So the results here, so from days 0 to 14, which is 56 to 69 kilograms for weight, there was no effect on the stocking density observed for the average daily feed intake. However, days 14 to 28, pigs had had an increase of the average daily feed intake of 0.05. And these are the pigs that were provided more space as opposed to the space that's recommended. Days 28 to 45, there was no evidence in change for this time period. And for days 45 to 62, the provided pigs that had 0.91 meters squared of space end up being heavier than the ones provided with the smaller space. Day 62 to 71 basically confirms that the ADG decreased when pigs were only allowed the smaller grazing area. So for the overall study, the span of 66 to 124 kilograms, the pigs that were provided 0.091 meters squared increased the AGP by 0.001 over the pigs provided with the 0.63 meters squared. So in conclusion, the pigs provided the 0.91 meters squared grew faster and consumed more feed than the pigs provided the 0.063 meters squared. We also found out and solidified the benefit from removing the heaviest pig from the space. Increasing the space by removing the pigs or gate adjustment increased ADG compared with pigs provided with the 0.63 meters squared for the entire experiment. And they found out then in the end that the critical value of 0.0336 actually may not be adequate for the optimal pig spacing for the body weight ranges that they have out. And that is it. Thank you so much.